Hello, how are you? Welcome again to Mr. Martin or Martin's Mwalim channel. Today we are going to look at lesson 3 of the topic magnetism, and I hope the last lesson for this topic. And in this lesson, we will look at the methods of magnetization, how to convert a material, a magnetic material, to be a magnet. And among the methods, we have 4 methods that can be used to magnetize a magnetic material. All of them including the first method is induction, second method is stroking, third method is use of electric current, and the last one is hammering. And the first thing, let's start with the method that we call induction. Now, if you have a magnet like this, you have a magnet like this with the north pole and south pole, and you bring a magnetic material near this magnet, let's say a pin, an iron pin which is attracted by a magnet. If you bring that pin near a magnet, this pin is attracted to the magnet and automatically the pin becomes magnet. That is the method of induction. Just direct, there is no much thing is done there. The pin becomes the magnet. How does it gain polarity? This end of the pin that is coming near the north pole, it gains an opposite pole. This end therefore gains a south pole. Therefore, the other end of the pin gains the north pole. Are we together? That is the method of induction. How does it happen? Whenever this pin is brought near a magnet, there are some things we call dipoles as we will explain about the domain theory hapo mbele kidogo, which are aligned to say face the same direction in magnetic field, making this pin to be a magnet. If we enter another pin which is brought near the same first pin, it would gain a south pole here and a north pole here. Na ukiangalia vizuri, the lower part is north pole, same poles, which will make the two pins to repel. Zina repel. That's why ukiziweka you will see them scattering as if they are repelling, they are moving away from each other wakati zimewekwa kwa one magnet. That is all about the magnetization by method of induction. The second method is the method of stroking. The method of stroking pia ina mambo mingi, but we have 2 methods of stroking. We can have a method that we call single stroking, or use of single magnet, single stroking. We also have a double stroking. Kuna double stroking pia, double stroking. And the first thing, we will start with the single stroking. How is single stroking done? A single stroking is done where, let's say this is the magnetic material we want it to magnetize. It's here. The magnetic material we are magnetizing, it's here. Then we can take a magnet like this, and then we will stroke. Tunaitembeza hivi, then tunainua hapa, so itakuwa inaingilia hapa, inatokea hapa. Like if this is the magnet, we do like this. That is what we are calling stroking. Inaingililia hapa, inatokea hapa. We do that procedure repeatedly, hence magnetizing this material. Let's say this is a magnet with the north pole and south pole. How does this magnetic material gain polarity? This end where it enters, hapa inaingililia, it gains the same pole with that of magnet. Kama hii sasa unaona magnet yenye inatumika iko na north pole, so this end where inaanzia, it gains north pole, na this other end pali inamalizia, it gains south pole. Are we together? The end where it ends, that end gains south pole. This is a single stroking method. We can also use two bar magnets, na tutumie mikono mbili, we stroke with the two ones, we stroke using two magnets like this. You can stroke using two magnets. Like we can have one bar magnet, one bar magnetic material, which is somehow long. We can have one magnet and another magnet this side. This may be north pole, south pole, north pole, south pole. Then this can be stroked a halfway. This can be stroked a halfway. While this other can also be stroked a halfway. Like this. It can be stroked like that. Una stroke mara mbili. What is the aim of this? If you look at the polarities that are against here, kama hii, unaona inaingililia hapa, meaning that this will gain north pole, na hapa pali inatokea will gain south pole, yes. Na hii nayo inaingililia hapa, this is north pole, and this other one will gain south pole. Therefore, this end of the magnet gains the north pole and the other end gains what? South pole. However, if we change the motion of this magnet, which is here, to key change, you will see what will happen. That if this was the material, this is the first magnet, north pole. This is the other magnet. This is the other magnet. North pole, south pole, and this is south pole. Therefore, let's change the motion of this. Hii ikue iko vile ilianzia. Natokea hapa. Na inayo, sasa hii itakuwa the other way. Inaingililia hapa, so that inatokea hapa. It is entering here. So hii ikiingia hapa, hapa kutakuwa north pole. It is entering here and leaving at this part, this becomes south pole. This is entering here, inaingililia hapa, this other hand, this becomes north pole, na hapa pali inatokea kunakuwa ni south pole. If you look at this magnet, is different from this, and utaona kwamba this one has gained south pole at the center and north pole at the other. And in this case, we say that this bar magnet has gained consequent poles. It has gained consequent poles. Therefore, this method of stroking, in fact, is the only method that can be used to produce a magnet with consequent poles. There is no any other method, and that is the advantage of the stroking method. It can be used to produce a magnet with consequent poles. Yes, that is all about the stroking method. The next method is about the electrical method. Electrical method, we will have to get that magnetic material. That magnetic material, then we will wound a wire. We will wound a wire around this magnetic material. We'll wound a wire again around this magnetic material like this. Then this wire is connected to a current, and direct current, not alternating current, but direct current. For example, if we end a switch here, and then we close a switch, if there was maybe some iron filings around, on closing the switch, it is found that this material here attracts what? The iron filings. Remember, whatever we magnetize is a magnetic material, e.g. iron, e.g. steel. If we close this switch, we find that this material starts attracting the iron filings. The reason is because whenever current flows through this coil, we also call it solenoid. it produces magnetic field, which in turn magnetizes this magnetic material. And that's how we can produce a magnet using an electrical method. It's most applicable, inatumika kwa several applications. Tutasisoma sana in the topic of effect of electric current on magnetic field, or effect of magnetic field on electric current. Therefore, this is the method of electric. Remember, we only use an direct current in magnetizing. And the last one is about hammering method. Is the simple among the simplest one. In this case, a material which is to be magnetized is placed such that it is facing north-south direction of the earth. It is facing north-south direction of the earth, and then it is hammered using an hammer. It is hammered using an hammer repeatedly, facing north-south direction of the earth. After several hammering, then this material is found to be a magnet after several hammering. That means this material, their dipoles, as I said, we will explain them in the domain theory. The dipoles of this material will be aligned in the same direction during this process of hammering. This is the hammering method. And again, if we have a magnet, now, the magnets that we have produced, and we want it to demagnetize, we want it to lose that magnetic property that it has gained, we can use the following method to demagnetize it. The first method is the method of hammering. The method of hammering. This time, hammering, you hammer the material while it is facing east-west direction. That is how you do it. If you hammer this material, which is a magnet, facing east-west direction, it will lose magnetism. Or you can use another method of electrical method, but this time around you use an alternating current. Instead of using direct current, you use an alternating current. The last method is of heating. If you heat magnet, it automatically loses its magnetism. That is the end of the lesson today. We will continue sometime later. Thank you.